So today we are going to start with the next part of our topic energetics. Okay. So last time we have done the two Born-Haber cycles. Okay. The first Born-Haber cycle that was based on the lattice enthalpy and formation. The second Born-Haber cycle that was based on the enthalpy change of solution and hydration. Okay, so these two cycles we have done. So we have to practice some more cycles with that. Okay, but before that, I'm going to tell you a little bit from the A1 syllabus. Okay, in the A1 syllabus, I told you the four formulas by which you can find out the enthalpy change of any reaction. Okay, so formula of enthalpy changes, I'm going to write it up here. Formula of enthalpy changes. Because these type of the A1 questions, they are present in the A2. So that's why I'm going to repeat it for you up here. So first of all, my dear students, the first thing that is based, this is the first rule, rule 1. So rule 1, that is EPR. So the word E for enthalpy change, delta H of reaction. So this is called as the enthalpy change is equal to the word P for products. So here we should write products and minus R for reactants. Okay. So when should you use this formula? When the values of the formation they are given in the question. So what should you do? You should subtract the formation of the products minus the reactants formation. Okay, so the reactants formation, so you should subtract the reactants formation from the products formation. Okay, so this is the first rule. E for enthalpy change, P for products, R for reactant. Okay, so this rule only employs when you got the formation values in the question. Okay, so we will practice those questions. Don't you worry. I'm going to tell you about it. Okay. So the second rule, rule 2. Rule 2 is ERP. If the values of the formation, they are not given in the question. You are given the values of combustion. You are given the values of the bond energies. Okay. So combustion, bond energies, all these values are given. You always have to use ERP. The word E again, that is enthalpy change of reaction. Okay, so this is the first formula. This is the second formula. Enthalpy change of reaction, R for reactants, minus P for products. Okay, so reactants combustion minus products combustion. So you should subtract. These things are present in your A1s, but I'm going to repeat it for you because these type of the questions they are also present in the A2. So number 3, my dear students, that is enthalpy change of formation of a substance. Okay, so that is equal to combustion of elements minus combustion of compound. So this formula is also based on the ERP, this rule. How? Let's suppose we got a compound C6H12. This is the compound. If I'm going to say you that what is the enthalpy change of formation, make the enthalpy change of formation for it. So what is the enthalpy change of formation? 1 mole of this compound is formed from its constituent elements. Carbon is the element, solid. We got 6 carbons, put 6 up here. The second element, that is hydrogen. Hydrogen exists in H2 form, gaseous. We got 12. So here you should write 6 2s and 12. Okay. So this thing is called as the enthalpy change of formation. So this is enthalpy change of formation. So if you look the element, And these are the elements, they are present in the reactants. And this is the compound, this is present in the products. So if the values of the combustion are present, so combustion of elements, so elements are present in the reactants. So reactant minus product. So these are the reactants, this is the product. So reactant minus product. Did you get it? And the last formula, my dear students, that is the enthalpy change. These formulas are very important because in paper one, you people haven't got too much time to make the Hess law. You should, these are the self-made formulas, these are not present in any book. Okay? So please just learn them, only learn these two rules, EPR and ERP. If the values of the formation are given in the question, nothing is written, then we should use EPR. But if the combustion and formation, these things are mixed up, okay, then we should always use ERP, reactant minus products. Okay, so the last formula, enthalpy change of reaction, that is also bond breaking minus bond making. Bond breaking always takes place in the reactants. Okay, and bond making, that always takes place in the products. Okay, so these four are the formulas, my dear. 1, 2, 3, and 4. So these four formulas, by using these formulas, you can solve any question in which the Hess law is being employed. Okay, so just learn these formulas. These were present in your A1 as well. Okay, so now I'm going to share the screen with you people, and we are going to start with the question. So the students which are new, particularly you, where maybe you would not be able to understand the questions today, but if you listen the recordings, then you can get it. So don't worry if you did not get anything. Okay.
Yes, sir.
Okay, guys, I'm going to share a screen with you, and then we are going to do this question. So I'm going to give you the question C part 1. Just do it. C part 1. Okay, my dear, everybody just listen. If you people use this formula, just listen. Yesterday we have done this formula, delta H of solution, that is equal to reverse of lattice energy plus, everybody just listen, plus hydration of positive ion and plus hydration of negative ion. Okay, so if you use this formula, so we are provided with the hydration of positive ion magnesium, it's okay, this is given. We are given the lattice energy, this is okay. We are not given the hydration of the negative ion in the question. So we won't be able to find out the enthalpy change of solution using this formula. तो पहला है बस ऐसे मैं सर बताने लगा नहीं पहला कौन है बस साइकिल नहीं बताने लगा just give me a minute. So it means this formula cannot be employed. He has given you the two values up here. See what is written, delta H of formation of MgCl2 solid and delta H of formation of MgCl2 aqueous. So yesterday we have done the definition of the enthalpy change of solution. Enthalpy change of solution is what? If you take 1 mole of ionic compound MgCl2, okay, it's a solid. So if you put it into the excess of water, it will form the aqueous ions. So in spite of writing the ions, you should write it MgCl2 aqueous, that is also okay. Okay. So if you could write it like that, Mg plus 2 aqueous ions, or you write 2Cl negative aqueous ions, so this is also correct. But if you write MgCl2 aqueous, that is also correct. So if you see, you are given the values of the formation. So I told you the values of the formation are given, which formula, which rule you should use, EPR. Okay, EPR is what? Enthalpy change of reaction is equal to P for products minus R for reactant. So product, so this is the product. So MgCl2 aqueous. So MgCl2 aqueous energy is minus 801. Okay, and then minus the reactant, that is MgCl2 solid. This is present on reactant side. So solid MgCl2 formation is minus 641. So if you solve it, minus 801 plus 641, so it would be plus 160. Okay, so plus 160, that is the enthalpy change of solution. Did you get it? I think minus, yeah, sorry, minus. It's minus 160. Okay? Yes, guys, online students, can you please say yes to me?
Yes, yes, sir.
Please take a screenshot of it. After that, you could practice it. You should know. Okay, the question is not completed yet. So this is the enthalpy change of solution minus 160. Keep this thing in your mind. Now, what he is going to ask you in the next question, can I rub this one? सर ये पहली इक्वेशन अप्लाई नहीं हो सकती क्योंकि आपके पास नेगेटिव आयन की हाइड्रेशन नहीं है क्वेश्चन में, नहीं है ना, तो ये तो अप्लाई नहीं हो सकता। तो ऊपर तुम्हें ये सॉलिड और एक्वस की जो है वो फॉर्मेशन दी है, तो भाई सॉलिड और एक्वस की फॉर्मेशन अगर तुम्हें दी हुई है तो इसका मतलब ये है कि फॉर्मेशन जब गिवन हो तो ईपीआर लगाते हैं, प्रोडक्ट माइनस रिएक्टेंट। तो MgCl2 सॉलिड से MgCl2 एक्वस बनता है जब उसको पानी में डालते हैं। ठीक है, तो उस फॉर्मूले से तुमने ईपीआर से वो निकाला enthalpy change of solution। क्लियर हो गया? ओके गाइस, कैन आई रब दिस वन? Guys, can I rub this one?
Yes, sir.
Okay. Now you have to do this question. You have to find out the enthalpy change of hydration of chloride ion. Negative ion की आपने hydration निकालनी है, so you have to calculate it. Okay. So find out the enthalpy change of hydration of chloride ion, Cl minus. So just do it. Now you should use that formula. Okay. Whatever we have written before, and what was that? Delta H of solution, that is equal to reverse of lattice energy plus hydration of positive ion plus hydration of negative ion. Now put the value up here. This is negative. Lattice energy value, if you look up here, this is minus 2526, minus 2526 plus hydration of positive ion. Your formula is MgCl2. So MgCl2 means it produces one positive ion, one Mg plus 2, and it got two chloride ions, so 2 Cl minus. So one positive ion is produced. So positive ion hydration is given in the question. Okay, what is that? Minus 1890. So you should write minus 1890. Okay, plus hydration of negative ion. Hydration of negative ion you have to calculate. So we got the two negative ions. So here we should write 2x, and enthalpy change of solution we calculate, that was minus 160. So if you solve it up, you find out the value of x, that would be the enthalpy change of chloride ion hydration. Minus 398. Okay, my dear. Now I'm going to give you one more question. So let's see if you people are able to do it or not. So this is the question, my dear. So just do it. The values are given in the table. So you have to find out the enthalpy change. Plus 201 है आपका. Okay, that's fine. Check कर लेते हैं. So if you look up here, the values of the formation, they are given in the question. So it means you should use the rule EPR. So EPR means enthalpy change of reaction, that is equal to product minus reactant. So these are the products, my dear. So NO2, if you see the NO2 value, that is plus 33.2, and here the 2 is written, so you should multiply it with 2. Okay, and then plus, this is oxygen. Oxygen is a single element. I told you the formation of an element, that is always 0. So this is 0, my dear. Okay, so now the products are finished, put them in the square brackets minus reactants. Sorry. This is also the product. I'm sorry. So positive. Copper oxide is minus 15. So minus 157.3. Okay. Now put them in the square brackets and minus. These are the reactant. Copper nitrate. So copper nitrate is minus 302.9. Okay. Now if you solve it, you will get the answer. So just do it and let me know what you get it. Okay, guys. This is the question, and for this question you have to find out the D part. D part is you have to find out the standard enthalpy change of formation. Okay, so enthalpy change of formation you have to calculate it. Okay, and the values are given in the question in the table. So these values are given. Okay, now draw the bond hammer cycle and let me know what is your answer. फॉर्मेशन बताया तुमने RAS इसकी डेल्टा एच ऑफ फॉर्मेशन यू हैव टू कैलकुलेट. ओके गाइस, ये मैं खुद करके देता हूं. एवरीबॉडी जस्ट लुक. फर्स्ट ऑफ ऑल यू शुड राइट द compound as it is RAS. This is the compound. Okay. Now in the first step you should make the formation of it. ये किन किन एलिमेंट से मिलके बना है? It is made up of radium, which is solid. Okay, and it is made up of sulfur. Sulfur exists in S8 form. It is also solid. And here we got only one sulfur, so here we should write 1/8. Okay, so this is the enthalpy change of formation. So this one we have to calculate. Did you get it? Now, if you look up here, my dear, here you don't need to draw the atomization and first and second ionization energy, all these things. If you look up here in the question, radium solid changes into radium plus 2. So atomization, first and second ionization energy sum is given up here. So what should you do? You should change directly into Ra plus 2 gaseous form and write this thing as it is, 1/8 S8 solid. Okay, so radium changes into radium plus 2, so its value is plus 1619. Okay, and just like that, now change this one into gaseous sign. So you look this equation, 1/8 S8 sulfur, it changes into S minus 2. So atomization, first and second electron affinity are all present in this equation. So what should you do? You should write radium solid plus sulfur minus 2 gaseous form. Okay, and this one, that is plus 555. Okay, now these two things, they have changed into the gaseous ions. Sorry, this is the gaseous ion answer. So these two things change into gaseous ions. So when they attract each other, they form this ionic compound, and this is the lattice energy. Lattice energy is given in the question, that is minus 2612. Now this cycle is going to start from the place where tails are present. This is tail, this is tail. So this is the starting point and the end point where all the heads are present. Head. So this is the end point. So from start to end, this is the delta H of formation. So here you should write enthalpy change of formation. That is equal to, you have to calculate this one. Then plus 1619 and then plus 555 and then minus 2612. So if you solve it up, you will get the answer. You got it? Yes. Okay guys, for this question, you are supposed to find out the enthalpy change of formation of calcium oxide. So this is the data given. Okay, so what you are supposed to do, calcium oxide enthalpy change of formation. So you are supposed to find out. Come on, Fatma, Muskan. Minus 684. One of the students find out this 64. 634. Okay, so let's do this question as well. So the calcium oxide you should write at the bottom.
make the formation of it, it is made up of the two elements, calcium solid, and the second element is oxygen. Oxygen exists in O2 form, gaseous. So we got one oxygen up here, so put half up here. Okay, so this is, my dear, enthalpy change of formation. So this one we have to calculate. So formation we have to calculate it. Okay, now these are the two elements, calcium. If you see, the calcium solid changes into calcium ion. So atomization, first and second ionization energy as a whole present up here. So this is 1933. So change this one into calcium plus 2 gaseous form plus write this thing as it is, half O2 gaseous form. Okay, so its value is 1933. Okay, now change this half O2 into gaseous ion. So its value is 950. So calcium plus 2 plus 2 gaseous form plus O minus 2 gaseous form. Okay, so this one, my dear students, that is 950. Okay, now this one change into calcium oxide. So this is the lattice energy, its value is minus 3517. Okay, so this cycle is going to start from here and end up here. So I think delta H of formation, that is equal to plus 1933 plus 950 and minus 3517. So now you can do it. Okay. Okay, now guys, what you are supposed to do, I have sent you the two worksheets, okay, in the group. So what should you do? You should solve all the questions relating to the Bonhoeffer cycles from the two worksheets. And if you are stuck at any question, you can come to me directly. Tomorrow you should say to me that we are unable to understand this thing, and we will discuss that particular question with you.